In the Aristotelian sense, a first principle is a foundation of knowledge upon which other knowledge depends, but which cannot itself be proven. Once you're at the bottom, there is nothing further to be gained by digging. Aristotle begins his metaphysics with the claim that something cannot both be and not be. This is so obviously logical that it boggles the mind to imagine it needs to be said, let alone defended, but Aristotle devotes chapters of prose to accomplish just that. The statement that something cannot be, and also not be, is the basis of logic. It cannot be proven by deeper logic. There is no deeper logic. If you won't accept it, then you don't accept logic. And there's no use in reasoning with you because something other than reason sets your epistemological standard. A computer program, ultimately composed of ones and zeros, does not suffer from the misapprehension that a 0 and a 1 can coexist. There is no way for the programmer to input both 0 and 1 at the same time, and there is no way for the computer hardware to read a 0 and a 1 at the same time and place. The world itself follows logic, and the computer is a piece of the world. Interestingly, a computer algorithm, by my reckoning, would be unable to determine the truth or falsity of a basic logical necessity like the one Aristotle begins with. For example, let's ask a logic machine to answer this question. Is there an even number which follows another even number? The algorithm begins with 1, divides the number by 2, and gives the answer. The next step is to determine whether the answer is a whole number or a fraction. If it is a whole number, then the original number was even. If it is a fraction, then the original number was odd. The algorithm stores this answer and proceeds. It returns to the original number and adds 1. This yields 2, which it divides by 2 and carries out the rest of the steps. It will show odd, even, odd, even, odd, even in perpetuity. But the algorithm will not be able to answer our question. It will just keep going until it arrives at 2 evens in a row, which, as we can easily infer, will never happen. The algorithm is a logic machine. It uses logic as its starting set of innate principles. It cannot derive its own principles. Imagine an algorithm for comparing two lists of numbers to answer the question, are the two numbers ever both equal and unequal? It doesn't even make sense to run such a program. The result is self-evident, but the computer doesn't know that unless we tell it so up front. You can't prove a negative. I guess that's the pithy way to say it. Yet, you and I know all kinds of negatives with total confidence. Actually, this line of reasoning is what led Roger Penrose to declare the human mind to be non-computational. I agree that the mind is not a computation, but I come to that conclusion from a different direction. Also, I admit that a lot of what goes on in the nervous system is computational, but only in a sense that is common to natural processes. Biochemistry is a complex business, and it doesn't have an organized linear code like a well-made piece of software. Actually, the cell's biochemical processes, having arisen by random changes in natural selection, are reminiscent of how a deep learning program might solve problems. The code, if you like, was never meant to be well organized and easy to follow. It does the job exactly according to its mandate: improve, or at least don't go backward. Imagine a single-celled organism living in the scum of a pond. It takes in nutrients and water, it fights off invading molecules, it avoids excessive heat, moves cilia, and from time to time it reproduces itself. Suppose reproduction is costly in terms of energy, but is a primary survival strategy for the organism. In coming to a complete understanding of this cell, with all of the chemical pathways that it undertakes, and it probably has thousands, one could be forgiven for claiming that the cell computes whether the time is ideal for reproduction, and if it is, undergoes mitosis. Neurons are just cells. The firing of an action potential is determined by electrochemical variables. Thus, it could be said to compute its firing pattern from the sum of all of its inputs, given its resting state conditions. The problem with this framing, though, is that it's too permissive. After all, are we to call events in the weather computations? Don't the molecules in the atmosphere, given their local temperatures and pressures, effectively compute the weather? A model of the molecules in the atmosphere, given local temperatures and pressures, would indeed compute the weather. Naturally, it would be imperfect, but this is only due to its limitation in available data. A kind of Laplace's demon of weather, having all of the relevant data at its finest possible grain, would of course have no problems predicting the weather. It seems to me that this example, though, the model of the weather and the actual weather, is a classic example of the map and the territory. By analogy, consciousness is necessarily something real. We know this to be the case more than we know anything. It cannot be a computational process. Consciousness itself is a territory, not a map. Interestingly, the contents of consciousness with respect to a putative outside world are the features of a map of that outside world. It's like this. Consciousness is physically real. The world is physically real. The relationship between human consciousness and the world is that the contents of consciousness compose a model of a self situated in a model of the world. This is where Descartes got it wrong. He suggested that consciousness is non-physical and that the world is physical, two entirely separate realms in mysterious contact with one another. Rather, I think consciousness is physical and contained within the world, but it presents as a local model of the world. Human consciousness presents as a model of the world adapted for individual human use. So qualia like colors and panes and all the rest are utilized as characteristics on a map. The qualia are real, and the color red has nothing to do with the electromagnetic spectrum of the objective world, which is also real. Apparently, it is useful to manifest the color red as an indicator of certain wavelengths of electromagnetic radiation. It's also useful on a road map to use red lines to designate political borders, but nobody expects to see bold red walls appearing on the landscape as they approach the state line of Ohio. The meanings of data presented to us as contents are biased toward the best interest of the evolved human animal. Also, like any model, it is necessarily made from incomplete data. This is a very interesting case of maps and territories. Again, consciousness is real. You and I both know this to be the case, with the same strength that we know Aristotle's first principle that something cannot be and not be. This means that consciousness is a territory. Generally, we assume that there is also a real universe outside of consciousness. That universe is territory too. But an individual conscious entity like you or me is known to exist inside the universe upon a physical substrate of the brain. This brain, in my case, that brain in yours. These brains fall inside the bounds of the real universe. They thus fall at some place in time on a geometrical map of the universe. A conscious entity exists with each functioning brain, sharing its place in time. Since we've understood that consciousness is a territory, just as the physical universe is a territory, we now have one territory embedded in another. Consciousness is a territory inside of a larger territory, right? Sure, but notice this too. The whole exercise we just accomplished occurred inside of your mind, within you. Everything you see or hear or have ever seen or heard, everything you know or think you know or have ever known is inside of consciousness by necessity. Thus, the universe you ponder exists inside of you. You access it like a map rather than a territory. The world, as you know it, is a map inside of you. You've never visited the real territory of a real world, and you never will. Nobody has. You have only wandered your own territory, that of consciousness, visited your own sights, seen your own territory of colors and shapes and distances, heard your own highs and lows of pitch. Each of these is a feature of consciousness, in no way akin to a feature of the objective world. In what sense does the world outside even admit of features? And yet, we understand that indirect signals, reflections of electromagnetic radiation, waves pulsing through material media, make a difference to receiving organs of the body, biological antennae. None of these indirect signals has anything more than an arbitrary relationship to the sensations and perceptions we enjoy. This relationship, this mapping of the world outside which the brain achieves for us, this is the easy problem of consciousness. What is the relationship between the map of the world and the territory of the mind? Easy, once the hard problem is in hand. What is the hard problem? The hard problem is this. What is the territory of the mind? What is this thing that experiences color and taste and sorrow and joy? These things are real. They exist prior to any mapping to the outside world. Evolution has seen fit to accompany these sensations to appropriate conditions for the organism's best interest. That's clear enough. But when a mapmaker chooses to use blue ink to mark the place of a river, he does not create the concept blue for this purpose. He couples an existing blue to an existing river. He says, this color shall denote river. He pairs two otherwise unlinked things. The things really exist. In order to couple a sensation to a physical condition occurring in the brain, both the brain and the sensation must exist to be coupled. The hard problem of consciousness is to explain what sensations are. Could it be that we're not up to the task? We just know, as Aristotle did, that something cannot both be and not be? We can't explain it. We can't prove it. It is the bottom-level truth, the thing itself. Not logical, but the very thing, logic, that the adjective logical denotes when we apply it to a statement. If consciousness is rock-bottom foundational reality, then it's no wonder we can't prove its existence. It is the very thing upon which all proofs depend. Okay, now let me try and steer this conversation toward the topic I intended to get to. There's been a lot of talk and excitement around the recent developments with AI, in particular ChatGPT. I read a paper by Christoph Durt, Tom Froese, and Thomas Fuchs called Against AI Understanding and Sentience, Large Language Models, Meaning, and the Patterns of Human Language Use. The authors write, quote, the exclusive distinction between syntax and semantics, or form and meaning, seems neat and plausible. However, if computation concerns only syntax or form and meaning something outside of language, it is all the more surprising that mere computation of language can lead to results that appear as if they would involve understanding of meaning. If large language models are trained only on the form of language, how can they possibly recombine the form in such a way that the resulting text has new and relevant meaning? Large language models challenge us to rethink the relationship between syntax, semantics, form, meaning, and more generally, between language, mind, and world. It is thus not enough to simply update the classical arguments. We also need to inquire into their presuppositions, unquote. Here, the authors seem to be suggesting that the philosophical distinction between syntax and semantics, as best exemplified in John Searle's Chinese room thought experiment, is incomplete. The evidence for this is that large language models such as ChatGPT often make original, meaningful statements that make sense to us. Yet of necessity, these AI programs are only provided with massive datasets comprised of human language. They're not taught to read and write, simply to output human-like language given a massive set of examples. Personally, I'm disposed to think that these programs are charlatans. They have no idea what they are saying at all, just like the man in the Chinese room, or my PlayStation console when it is running a session of Call of Duty. The game system doesn't know that the long strings of ones and zeros comprise a three-dimensional landscape for players to conduct battles on. Yet when I'm playing, I am seeing just that. Of course, there were human designers for a game like Call of Duty, but we are likely to see such games soon enough being put together by artificial intelligences. So what should we make of all this? There is no consciousness in them, so how do these systems work so well to produce what is meaningful to beings who are conscious? Let's return to the topic of large language models. Durt, Froese, and Fuchs write, quote, in this paper we do not follow the typical patterns of argumentation. We neither draw an exclusive distinction between form and meaning, nor do we speculate about AI developing understanding or sentience. We are here also not singling out something that is unique to humans and could never be replicated or simulated by computational systems. Rather, we investigate the features of the human mind and language that allow language to be processed statistically in such a way that the output makes sense to humans. We agree that large language models should not be ascribed understanding or consciousness, but for a different reason. We think there is a better explanation for their ability to produce texts that, at least on the surface, strikingly resemble those produced by humans. We contend that the reason for large language models' language processing abilities has little to do with their supposed similarity to humans, and a lot with the structures and patterns in human language use. Language use lends itself to computational processing because its structures and patterns can be rearranged in ways that make new sense to humans, unquote. They go on, quote, "The role of these structures and patterns is easily overlooked under the standard picture of meaning, according to which meaning can be detached from language, which is thought to be a mere formal system. The problem that resurfaces in the context of large language models is that the standard picture does not account for the extent to which meaning is intertwined with the use of language, including descriptions, worldly interactions, writing, and verbal thought. Regarding the relationship between meaning and the use of language, Wittgenstein writes in his logical investigations, for a large class of cases of the employment of the word meaning, though not for all, this word can be explained in this way. The meaning of a word is its use in the language, and the meaning of a name is sometimes explained by pointing to its bearer." Wittgenstein admits that the common picture has some explanatory power. The deictic reference to a name can sometimes explain its meaning, but this does not allow the inference that the meaning of a name is its bearer, nor that other forms of meaning can be adequately described in terms of naming. Instead of applying some clean but artificial definition of meaning, Wittgenstein demands to consider the actual use of the word, by which it does not merely mean statistical relations to a text corpus, but the use of the word in language games, unquote. It would seem that the authors of this paper are trying to parse a distinction between two different ideas which are normally captured in what we call meaning. There's something like a baby in the bathwater being hinted at, like perhaps John Searle's thought experiment misses something. I haven't quite seen it yet, but I admit to the possibility. They quote from Wittgenstein, who says that in most but not all cases, the meaning of a word is its usage, as distinct from the pre-existing idea to which it refers. Let's take another passage and see if we can make further sense of this. The authors write, quote, "Recent large language models show that the extent to which meaning can be produced by mere statistical means is much greater than linguists and computer scientists had believed. We suggest that the reason is that large language models not just represent general structures, but the part of the use of language that is represented in their training data. Bender and Kohler are right that Wittgenstein's concept of use refers to language used in the real world. But this does not mean that the distribution in a text corpus would be independent of use of language. The idea of a semantic distributional structure of language, that words that occur in similar contexts tend to have similar meanings, is called the distributional hypothesis or distributional semantics. Distributional semantics is contrasted with denotational semantics or theory of reference. We agree with distributional semantics that human language use is reflected in the text corpus with the important restriction that it is only part of the meaning that is reflected, and only in incomplete ways. Modeling language use entails the modeling of meaning, even if only in limited and distorted ways. By modeling language use, large language models learn syntactic and semantic structures in addition to syntactic and semantic patterns," unquote. All right, I don't know if that helped you, but I got something out of it. There is a statistical relationship being discovered and used by the AI that reflects context. This means it seems as though the AI is modeling meaningful speech. In fact, it is modeling the modeling of meaningful speech. It's more like a screenwriter than a first-person speaker. It is acting out a role, outputting what an intelligent real person would statistically say given the inputs. That's pretty much what I would have thought. It's a charlatan, a bullshitter. The authors are suggesting that these programs are capable of making compelling speech in this manner without having access to the other type of meaning, meaning as reference to ideas. I can try to pull this episode together at this point. At the beginning, I was talking about the difference between a map and a territory. I said that consciousness is territory, not a map, but that the contents of consciousness take the form of a map. What I meant was that a feature on the map is meaningful and that it refers to a feature on some other real territory. In that sense, when we speak, we are using words as codes to call specific concepts to mind. Language is a map of a conceptual territory. The AI programs are becoming great at outputting language which we regard as meaningful. The AI program is doing so not by accessing the ideas to which it refers, but simply by using statistics and very large sets of linguistic data. It is thus mapping a map, not mapping a territory. It is bullshitting. What they call AGI, or artificial general intelligence, would be a real territory. It would be like something to be such a system. Until then, AI is just a map. Now here's the next question. How often are real humans just charlatans? For the most part, are people just intelligent language modelers too? Just ejaculating nonsense out of their mouths in the style of real human speakers? Perhaps more than we would like to think. I mean, I'm not confident that most people ever really have an original thought. And on the rare occasion when they do, it probably makes them self-conscious, so they just keep it to themselves, like a dirty secret.